Welcome to Advanced Functions MHF4U1. This is Combinations of Functions chapter. In this lesson number 3, we're going to represent the product of two functions graphically and algebraically. Let's go over the definitions of the product of two functions. So as you can see, when f of g is together with the input of x, you could separate it into two different functions, f of x times g of x. So you could put it together right beside the letter, or you could put a multiplication sign. It means the same thing. The domain of the product of two functions is exactly the same as what we did for addition and subtraction. The domain is where the domain for the function f intersects with the domain of function g. And that will be my new domain of the new function. So let's try an example. Example 1. So we're given function f of x and g of x as a list of points, and we want to figure out the product of two combined functions. So then, let's find the domain for f times g. So where do they overlap? So it looks like they overlap at 2 and they overlap at 3. Okay? So once you figured out where they intersect, then what we can do is we could evaluate the y value. So f times g of x is equal to, so 2 stays the same, but for the y value we're going to multiply. So negative 5 times negative 2. And then we have 3, 7 times 3. Then we could simplify this. So it's 2, 10, and 3, 21. And that is my final answer for product of the combination of two functions. Okay, so now we're given an equation, square root of x, and we're given a linear function. So we need to figure out f times g of x. So this means that we are going to multiply f, which is square root of x, times g, 1 over 2x minus 2. Okay. So in this case, you could expand it, or you could just leave it like this as well. Okay, because we don't really have a like term. But if you do want to expand it, square root of x, essentially it's 1 over 2, right? Times 1 over 2x minus 2. So you could say 1 over 2x, 3 over 2, minus 2x, 1 over 2. Okay. Now, but keep in mind, we do have to say x has to be greater than or equal to 0. Why? Because the domain for my function f is where x is greater than or equal to 0, while for this one, for function g, it's linear. So you have to figure out where they overlap. Okay, what about when the input is 4? So what you can do is you could just insert it right away into this simplified version. So square root of, instead of x, I'm going to write 4. That's my input. And then 1 over 2 times 4 minus 2. So 2 times 2 minus 2, it's 0. Okay. So when the input is 4, the product of two functions is going to give me 0. And then when the input is negative 1, so as you can see, when negative 1, if I plug it in, it's going to be square root of negative 1, 1 over 2, negative 1 minus 2. But square root of -1, it does not exist. It's undefined because my input here is -1. We want x to be greater than or equal to 0. So therefore, just by looking at it, this one, it's going to be, we know it's going to be undefined. So therefore, it does not exist. Okay. So please keep in mind when you're multiplying or even adding or subtracting, you have to look at individual domain to make sure that they overlap. Okay, so what if we're given a graph this time? So we're given a graph of f and g, and we're looking for f times g. So first things first, let's figure out the clear points. So this point at -3, and let's do -1 and 0. And let's try this point. Okay, so at -3, we are going to multiply 3.5 times -2. So 3.5 times -2 is going to give me -7 at 3. So it's going to be really, really bottom over here. At x, when x is -1, 0 times -0.5 is going to give me 0. And why don't we do -2 as well? So 1 times -1 is going to give me -1. And then at 1, we could do 2 times -0.5 is going to give me -1. And at 3, 4 times 3 is going to be 12, so it's going to be really, really high up over here. And then I could do, why don't we try at 2? So 1 times 3 is 3. Okay, so as you can see, we can connect the points, so it's going to look something like this. And then at 1 times -1 is going to be -1, so it stays the same. So it looks like that, looks like this, and connect the points with the arrow. Okay, so this is when f times g, the new function when we combine by product rule. Question 4. So find the domain of the product of the given function. So we're given exponential and sine x. So for domain for the function f, for exponential, it's going to be any real number, right? It looks like this. So domain x can be any real number. For domain for function g, it's sinusoidal. Sinusoidal, it's continuing forever and ever, right? So x can be any real number. So therefore, the domain f times g is going to be x can be any real number. Next, so we're given a reciprocal function. So reciprocal function, it looks like we have a vertical asymptote at 2. So it's going to look something like this. And we're given a log function. So it looks like that. So domain for function f is x can be any real number, but x cannot be equal to 2. And for g of x, x can be any real number, but x has to be greater than 0. So where do they overlap? Well, it looks like x can be between 0 and 2, right? So it's 0 and 2, or 2 and above, right? Because x can be any real number except for 2, but it has to be greater than 0. So in between 0 and 2 and infinity. So if you want to have a better visualization, what you can do is draw a line graph. So this is at 2. So for the first graph, it looks like open circle, and it looks like this, and this. Okay, and this is 0. But for the second graph, x has to be greater than 0. So it's going to be open circle, and it goes this way, right? So where do they intersect? They intersect in between 0 and 2, and 2 and beyond. So this will be my final answer.